Okay, we are recording. No student turn up, only you. So maybe they are frightened.
Yeah, nobody did.
Yeah, you say okay, opening to student. So
No,
opening
I
to
say okay, but nobody came in also.
nobody turn up. Maybe they are too frightened to turn. They are frightened of you.
I'm
You too
frightened of me, I
garang.
never say anything. What?
No lah, joking with you. Don't take it seriously. Okay, let's see. What do you say you get?
44.
44, okay lah. But still need to work on your weakness.
I need to get 60.
Right? This is 3 and 4 wrong. 6 is wrong.
Oh my god.
6 is wrong. 8, 9, 10, 11, 12 wrong. 14 wrong, 15 wrong, 16 wrong, 17 wrong, 21 wrong. Let me just record it down so that you can 17 wrong. Hold on. Computer is very slow today. Don't know why.
Okay.
17 is wrong.
So maybe your space is little, so that's why your computer is
Say again.
Maybe your space is little.
My space is little. What do you mean?
No, sometimes if your space, your computer space little means then your computer runs slowly. That's what I mean, so.
Computer is near the modem.
No. What I mean is because do you store things in your computer? So all the study files, everything.
Too many things is it?
Maybe lah. That's why it's slow. Or else it will be
Okay.
moving fast. Maybe teachers should buy a pen drive, the 1 terabyte hard drive, and then store all your backup files like that. Then maybe the computer.
That's one thing to think about. Okay, we'll try to do that. 21 is wrong. I just want to record down for you to see where you are weak in, and you have to work on that. 21 is wrong. Okay, the last one, 25 is wrong. Okay, 22, 23, 24. Okay, 25 is wrong. Let me just record it down for you to see in case you are asking where you got wrong. So you have to work on your weakness. No shortcut. You don't work on your weakness.
Revision in all the topic back again.
Yeah, revision, you have to concentrate on your weakness. I observe where is your weakness. I can only point out to you.
My weakness, the hard questions.
Okay, let us go over. Let me
Okay.
why is it so slow? Okay. Let's go over the question. Okay, this one, yeah, all right. More or less memory work. You have forgotten, know how to write, know that sometimes they won't write for you. You should put your own internal resistor inside there and know how to use Kirchhoff's voltage law to write the equation. That E is just your that V. That V is across that variable resistor plus your I times your R. I is a current through the circuit. What is meant by electromotive force? Right? That is your definition. You must memorize it. So the first one is the answer. A. Number 3, very poor. A battery with EMF E and internal resistance R is connected in series with a variable external resistor. The value of the external resistor R is slowly increased from 0 Which statement is correct? Ignore temperature effect. The potential difference across the external resistance cannot decrease, it must increase, because basically, remember, don't bother about the current. As you increase your R, the current will start to decrease. It will affect both of them. Think of it as you are sharing.
So what is question 1 and 2?
Question 1 and 2, yeah, right? The same is more or less the same topic.
I just want to see can answer.
Want to review, okay.
Just see only.
That's your question 1.
This one straightforward lah, yeah.
It's not straightforward. Just write the formula. If you can memorize it, memorize it. You not get it from here. Gradient is R, y-intercept. Electromotive force is your C.
Yeah.
That's a popular question. Then this one is definition of EMF. Memory work. Okay.
Yeah. There is no external, internal resistance and all. Donkey's wrong. Yeah.
As this one, always remember is sharing. Treat your source as a father. He has $10. He got 2 brothers. 2 brothers are the resistor.
Yeah.
If you give $5 to R, the other $5 go to the small r. You get $7 to big R, then the other will get 3R. Right? So as you increase the current, as you increase your R, means you are giving more money to big R, more potential difference to big R. Right? So the first one is wrong. Right? EMF is shared between this R and this big R. So as R increases, the PD across R increases, and across the small r decreases. Potential difference across internal resistance increases, cannot be. Okay, don't bother with that. Right? It's just that if you get more money here, increase in resistance, less money will go to the small r. That's all.
So that means you cannot, like the small r cannot get more money compared to the big r.
Cannot. It is constant. Right? It's constant. So you give more money to the big brother, big R, then you get less money. The EMF is fixed.
Oh, EMF constant.
Yes, cannot change one. Only the terminal potential difference changes because R changes.
So that means the correct answer should be C lah. That means
the power dissipated in R increases and then decreases, cannot. Right? Because the current start to decrease as you go higher and higher. So the power dissipator is going to start decreasing across R, but R is different, big R is different. Power dissipator increases first because you have larger resistance, so larger energy dissipated up to where the 2 is the same, 2 resistance is the same. After that, that is the maximum power dissipator in R. That's memory work. After that, the power start to decrease. Okay? As you increase R, the power dissipated in the big R increases until the 2 resistance are the same.
Then only the big R will decrease and then small R decrease.
The maximum power dissipated. After that, it decreases. Okay.
Then the small r will increase, right?
Small doesn't change. Always decreasing.
Oh, okay.
All right.
So let me get this straight, teacher. The EMF is constant. The EMF big R receives more power. Small r will keep on decreasing. R will keep on like increase until it reaches maximum, then it decreases. That's all, right?
Small r will start to decrease the minimum. Because big R will go to maximum. Yes. After that, as big R start to decrease, small r start to increase. Yes. Right? Remember, it's sharing.
Yeah, so that means big R decrease, then only the small r will increase. That's what I mean to say. Yeah.
Energy also the same. Potential difference is sharing, but energy is also the same.
Potential different is sharing, but energy is the same.
Okay, number 4 also wrong. Means you have not understand this part. The high resistance voltmeter connected across a battery reach 6 volt. Right? Imagine yourself. They won't give you a picture sometimes. You have to imagine yourself. When the battery is connected, right, this is 6 volt. When it's open circuit, that's connected in series with a lamp. Consider that as a lamp. Or resistance 10 ohm. The voltmeter reading falls to 5.6. Right? Why? Because there's an internal resistance inside there. We are measuring the potential across here. Which statement explains this observation? A. Electromotive force of battery decreases. Electromotive force cannot change, one is always constant. Right? Because more work is done across internal resistance. Work is done across internal resistance, yes. Energy is lost, but electromotive force cannot change. EMF of battery decreases because work is done across the lamp. Work is done across the lamp, correct. But as I said, EMF is always constant, cannot change. The potential difference across the battery decreases because work is done across the internal resistance. Right? When you connect to the lamp, it measures the voltmeter measures a terminal potential difference across this lamp. Some PD will always fall across the internal resistance. That's why you won't get this 5.6 and 6 the same, because some of it is some potential difference across the internal resistance. Right? The PD across the battery decreases because work is done on the lamp. It's not done on the lamp because there is work done on the internal resistance. Right? Whether if you don't have internal resistance, all the work is done on the battery, so it will still be equals to EMF. But because there's work done on the internal resistance, then the potential drop across the lamp is lower. Okay, C. Then
1 minute, sir.
energy loss is in the internal resistance because there's potential difference across the internal resistance. So that
EMF constant, okay. Voltmeter across the battery.
right, that 5.6 is across the external resistance, or we call it terminal potential difference.
So, teacher?
Yep.
So voltmeter, it only measures EMF when it has only high resistance, is it?
When it's only high resistance, when you open
Which
circuit.
resistance, teacher? The high one or the big one or the small one? Which one is?
No. It must be open circuit. It must be open circuit. That means you put your voltmeter across the battery. It must be open circuit. Then the voltmeter must be high resistance. Then it measures.
Closed circuit means don't care lah.
Then it measures the EMF. But when you close the switch, the voltmeter don't measure the EMF anymore. It measures the terminal potential difference. Right? It measures terminal potential difference. That's why it is now lower. Terminal potential difference means the potential difference across the external resistance. Right? Some of it is dropped across the internal resistance. Okay? Understand that?
Okay. So that means voltmeter can only measure the EMF when it's open circuit. Closed circuit means cannot, right?
Cannot. It must be also high resistance also.
Must be high resistance also.
Yes, high resistance.
And then if closed circuit means voltmeter doesn't have to do anything lah. Is it?
If it's high resistance, usually it draws very little current. So we won't more bother about it.
No. What I mean is voltmeter don't have to do anything, right? Actually.
Voltmeter just read only.
Read
only.
Okay.
The potential different. That's all. Or read the voltage.
But not the EMF when closed circuit.
Not the EMF. Unless you open circuit. Then it measures EMF.
Open circuit means it measures everything, right?
It measures just the EMF, that's all. Because it has high resistance, we won't bother about the small drop across the internal resistance. Yeah. Whereas when you close the switch, because of this external resistance, the resistance is low, then you got a potential drop across the external resistance. Okay?
Okay.
Okay, this one, yeah, all right. You can understand what is happening. You just
you use the formula E equals to I bracket
either use
R plus
formula,
small r.
know what you are doing, or use a formula. Right? There's 9 millivolt. That's your internal resistance. That's your external resistance, 30 ohm.
Yes.
What is the current in the galvanometer? This one is just simple, straightforward. Use a formula, put in your value. Right? So good that you know how to use that. Okay.
Okay.
Number 6 is just
This
you don't
one
understand.
I don't know.
Right?
Yeah.
It should be A.
Why?
Right? Power supply of the electromotive force. This is 12 volt. Imagine, just put in your head. Internal resistance is 2 ohm. It's connected in series with the external load. The value of the resistor is vary from 0.5 to 2 ohm. It's just testing whether you understand or not what I've been teaching you so far. Which graph shows the power dissipated in the load resistor varies with the resistance of the load resistor. So you want to know the power dissipated in the external load. That's all. So power dissipated, remember, as you increase that resistance, you are increasing the power dissipated across here, right? But across here, the current is smaller. This R is always constant. Only this R is changing, external one is changing. Small r is constant. So small r, the energy current starts decreasing. It's I square R, power dissipated, it becomes smaller and smaller. So it's more like here, right? Whereas this one is more like this one, increases to a maximum. Maximum occur when these two are the same resistance. That's why it's happening. About 2 there, right? Maximum power dissipated. After that, because as you increase more resistance, the current becomes less and less, right? So it's always I square R. So that's why it does decrease. This one, internal one start to increase again. Okay. So this is your
when they put the resistance or load, right, teacher?
Yeah.
Okay, that means do they include the big R and the small R also combined together?
This is a big R. This is a big R.
Yes,
This is a
yes,
small
that's the
R.
big R. Yes.
Small R is constant. Big R is
Small R
the
is
one changing.
constant. Okay, okay.
So the power across your big R start to increase until the internal resistance 2 ohm, external one is 2 ohm, then its maximum power dissipated. After that, it starts to decrease. That's what I've been trying to tell you. Gone over with you.
Okay. Okay. But why the small R is constant? How come?
Small R doesn't change. It's inside the battery. Only the external one we can change.
Wait, so for any question, small R and EMF is constant, is it?
Yes. Small R and EMF is constant, doesn't change.
And
We
the
cannot
previous
change what
question
is
we did just now?
same. We only change the external one.
Oh, okay.
Internal
That
one
means
cannot change.
okay. But then you said small R was like decreasing or something. Then one, teacher?
Not small R decreasing. The potential different. Understand the topic. Potential different is the one decreasing. Sharing. Right? It's
Teacher, can you go
sharing.
previous question, please?
You share the 12 volt between the big
Yes.
R and the small
Yes.
R. So as the
Yes.
big R increases,
Hmm.
your potential difference across that big R also increases, but this one becomes smaller and smaller.
Oh, the potential difference decreases,
Yes,
not
potential,
the value.
not the value.
Ah, okay.
Sharing is sharing. 12 volt is shared between the big R and the small R. Right?
So,
As big R increases, the potential difference increases. This one decreases.
yes.
Potential difference across small R decreases.
Hmm.
Okay.
Okay, so any question, EMF small r is constant, only the big R only can change. So
Big R
that
is
means
external. It's
it's
outside the
only
battery.
potential difference only varies between the
Only when
resistance.
potential difference can change
Okay, now I understand.
because the current is changing.
Okay, understood.
The sum of, this one is okay, sum of electrical current into a point in a circuit is equal to the sum of current out of circuit. Is your Kirchhoff's current law.
It's not the second law.
First law. So it's conservation of charge. Right? The others will be wrong. The last one is Kirchhoff's second law, result of conservation of energy. No, this second.
The answer can be either A or donkey, but you have to check which one is correct, A
This
or
is
either
current.
donkey.
This
Yeah,
is current.
based on the definition.
You
Yes.
must go to the definition. This is current. We are looking at current, not EMF and potential different. Always keep that in mind. Even though donkey is correct, but donkey doesn't satisfy the demand of the question. Which of the following is not true for resistor in series? Right? This one also you are very poor. Sum of PD across all the resistor equal to the source of EMF of negligible internal resistance. Right? Sum of PD across resistor equals to, okay, that's correct. Current through each resistor is the same. Right? Series is not. Series are correct. Sum of resistor to each resistor is the same because it's series. Combined resistor is always greater than the individual resistor. That's correct. You add all of them together, it must be greater than any component resistance. PD across each resistor is the same. No, unless it is parallel, then it's the same. Okay. These are fundamental. Revision review. This one also you are wrong. Two identical battery, each of 6 volt, 6 volt, and internal resistance RR. The battery are connected to a external resistance or resistance 11 ohm. As shown, the current in the external resistor is 0.5 ampere. What is the internal resistance R of each battery? Okay, how do we solve that? We are given current, we are given resistance, so we can find the potential difference across the 11 ohm. Right? Or we got terminal potential difference, V equals IR. As your current, as your resistance, multiply, we get 5.5 volt. Then remember, we are sharing that PD, that 6 volt there, is across that battery and across the internal resistance. So we can find, right, what is the potential difference across this small r. Right? It's just 6 minus your 5.5. 5.5 is across this here.
So 0.5.
0.5. So there is a potential different drop here. There's a potential different drop across here. Okay. Right? The current, remember that these two resistors are the same. This is the current. So this one, Kirchhoff's current law, the current through each of them must be the same. So each of them must be half of this value. Okay, that's why I divide by 2. Right? Each of them contribute half the current to give this 0.5. Right? So it's 0.25 ampere. So we have got potential difference. We have got the current. Now we can find the resistance R. So right, it's V over I. V is 0.5 across the small r. Divided by the current. Current is 0.25. So it's 2 ohm. B. Can.
Yep. Oh, I thought like a PD across R, then you take 0.5, then I thought times 2, then you get the answer already.
No, not so simple. You have to find the potential difference across this one first. That's why they give you the current. Then find the potential difference across the small r. Then find the current through the small r. Then you can calculate your R.
Okay. Wait, why 0.50 divide 2, not times?
Why times 2 for what? The current coming out from each battery is 0.25. Add together will give you 0.5.
Oh,
right? That's 0.25. Is 0.25 current law add together to give you 0.5.
oh, I thought each 0.5.
No, each is 0.25. You must apply a
Oh yeah, yeah,
current
only oh yeah, PD got only 0.5. That's why they divide two lah.
Kirchhoff's current
Yeah.
law.
Yes. So
Right? In case you've forgotten, it
0.25.
is Kirchhoff's current law. Kirchhoff's current law.
First one or second one?
Current law. Current law is the first one.
Oh, yeah.
You must be flexible to know the law, the name of the law.
Yeah.
Okay? You are very weak in this type of calculation because you have not done enough work. Okay?
Okay.
This one also you are very weak. I don't know why I keep on telling you. You are very weak. This is your SPM work. Right? The diagram shows the arrangement of resistor. Go and work on that.
Answer is boy.
Go and do your past year paper. What is the total in electrical resistance? Replace this one first. Replace that series one first. Right? Like this two. So the 10 still there. 10 plus 10 plus 10 is 30.
Yes.
Right? 3 resistors in series. And after that becomes parallel. Okay? 7.5 is less than 10. Okay? Cannot be less than 1. So the best answer is B. Any comment? Anything not clear?
No.
Okay. So you are very weak in this area. This one also very weak. Right? The diagram shows a circuit with 4
This one I don't understand, sir.
voltmeter. The equation relating the voltmeter reading must be true. Okay. So remember, if they didn't tell you anything, means the voltmeter has high resistance. So the voltmeter measures the EMF across here, measure the potential difference across here. So V2 and V3 must be the same. That you must be able to deduce. V2 equals to V3. Right? No different. They try to deceive you only. Then V is the EMF equals to V1 plus V2. Right? That's your Kirchhoff's voltage law. Second law. V1 plus V2 or V1 plus V3. V1 here, V2 here, add together. Then you take your V2, take your V1 across there, you get V minus V1 equals V2. Okay, then look for answer, donkey. Can? Any comment?
Oh, wait. Sir, can you repeat again this? I don't understand this one.
First, you must be able to look. V1, V2, and V3 is the same. Right? It's across the two resistors, that's all.
Then the V, teacher?
Then that is the EMF. That's from the battery. Right? So you are now applying Kirchhoff's voltage law. V1 plus V2 or V1 plus V3. That's what we do. Kirchhoff's voltage law. Yeah? There's a voltage. Okay, there's a voltage. V1 plus V2. Okay with that? Then the rest is just playing around the formula and see which is the right answer. Any comment? Anything not clear? Yep. Anything not clear? Okay, let's go to number 12.
But 11, why never include number V3?
Doesn't have to include V3. V3 and V2 are just distraction. Both of them are the same. You can replace that with V3 if you want to. But choose what is the answer. What's the right answer? Yeah, very straightforward. You don't know how to read, that's all. Right? V measures the EMF, no internal resistance here.
None of it
V2
measures internal
equals
resistance.
V3. They didn't say about internal resistance, so most likely no internal resistance. Yeah. What is the problem? Yeah, changing to a new Zoom to soon.
So that means no V3 lah, teacher, included in the equation.
V3 equals V2. That you must
Oh,
understand.
okay. Teacher, but
Must be
then
able to
there's
read.
R and 2R there. That's why I don't get it.
Doesn't matter. These are in parallel. So you can think of this as one resistor. When they are parallel, you can replace with a combined resistance. That's all.
Oh,
Don't let that
okay.
distract you. Examiner can put
Okay.
it very complicated circuit, but you must know how to read.
So that means it's basically to triggers only lah, teacher.
Yeah, no, make sure you know how to read, that's all. Don't
Okay.
test you straightforward, not like SPM. Right? This one also you cannot remember formula. That is very difficult for you. You don't remember. You're going to need in this topic, you need to remember formula. If not, derive it. That's your current. Right? So the current, that's your EMF. V0 is I, R1 plus R2. Then you want your I, take R1 plus R2 down. So it's V0, R1 plus R2. Then your potential across here is I current times R1. That's what we have here. Then replace this I with this one. That's why we get the formula. Right? But best is to remember this formula. V divided by V0 is R1. V0 is across R1 and R2. So R1 plus R2. Remember this formula. Yeah, still very weak because as I said, never do homework. Okay? Memorize formula faster. Rather than derive. Derive, you need to know how to derive. Okay?
Okay. Wait, so this is not a complicated question, lah, sir.
Oh, memorize only. Trying to revise with you, make sure you remember the formula. Right? This is the basic of this topic. You don't memorize formula, you're going to be in trouble. Right? Like this one you memorize correctly the formula. Right? It's the same as the previous topic. This is one resistance, this is another resistance. Okay, that's your ED. So memorize, right? You can call that name there. Right? That one you need to know. This one is across AC. That's why we got AC. And then this one is this one is ED. ED across AB. Memorize the formula. Potential divider, that's all. Right? And then put in your value. This is 60 over AB. AB is 100. Right? ED is 2. That one you got correct. Right? Same as the previous question, that's all. Except we use wire, that's all. Okay?
Okay.
Right? This one is a bit more challenging. I agree with you. But for this type of question, they say R is all the same. You can put value. Don't put one. One is very subjectional. Right? Put 2 or 3 or 4. Don't put too high. Make it easy for you to calculate. Because if not, the idea is objective one. You want to make the calculation as simple as possible and get the answer as fast as possible. Right? So I let the resistance be 2 ohm or any value. We can call it 3 ohm. But as I said, don't put 1 ohm. Right? May get the wrong answer. Right? So there are the resistors in parallel and the PD across is the same. Right? Right? PD across here is the same. Suppose the resistor is 2 ohm, any value, choose any value. Okay, so now I'm calculating the potential difference across here. This is 2 ohm, this is 2 ohm, so I get 4 ohm. Right? This is your I, that's your current. Multiply that. Then right? A3 is a current. Yeah, A3 is a current. Potential difference I calculated out 2.4. So 2.4 divided by R. R is 2 ohm. It's 1.2 ampere. Okay. Then this current is the potential difference divided by this 3R. Right? 3R is 2, so it's 6. That's why we get 6. Potential difference across here is 2.4 volt, 0.4. Then use Kirchhoff's current law, Kirchhoff's first law. Right? A2 is the one that supplies the current. The current goes to A3 and A4, and then go to A1. Right? That's why it's happening here. Right? So A2 is 0.6 plus 1.2, all that 1.2, 0.6 is this one. Right? A3 is 1.2, A4 is 0.4, 2.2, and check for answer donkey. Okay.
Okay.
This is challenging. As you work with formula, it's even more complicated. Right? Choose value, easier. This one also very weak. Right? Very weak. Answer is C. Right? Work with this one first. This one. Replace this one. These two you can see in series. So R plus R is 2R. This one is R, this one is R. Then these are all in parallel. 1 over R plus 1 over R plus 1 over 2R. And calculate R, R1. And for this one, replace this one first. These two is parallel. Replace with one resistor to this one. Right? So this is 2, we divide by 2. So you got half R. Right? R, half R. And this is in series. Replace that in series. Okay, so now you get R plus half R is 3 over 2R. Okay, so now this is in parallel. Calculate in parallel. Get this value. Same here. Right? This R plus R plus R is 3R. Replace that one first. Then this is in parallel. Calculate the parallel. Okay. Then choose which is the smallest, which is the largest. Right? That's the smallest. That's the largest. Can?
Can.
Okay, I think we'll take 5 minutes break. And then we'll carry on with the rest. Since our Zoom is almost finished. Any comment?
Thank you, teacher. Nope. Teacher.
Yep.
Like each of the physics topic in SEM 2 connected, teacher.
They are interrelated.
Interrelated.
Sometimes they may test you in between topic, but usually they are connected a little bit, if not a lot. Only electric field, only magnetic field, and electromagnetic induction, they are related to each other. But most of it are related very little only. Okay.
Oh, okay.
So we'll take 5 minutes break.
Okay, sir.
Let you refresh yourself.